In the previous lessons, we learned about using the periodic table to determine the charges of monoatomic ions, that is, an ions made of one single atom. So we can look at the group A to determine that 1A, 2A, 3A, the group number determine the charges of the specific element in that group. And then we go into 5A, 6A, 7A. That group number also directly related to the number of electrons need to be gained to be stable. Like for 5A, they all have 3 minus. For 6A, they will have 2 minus because they will gain 2 electrons to be stable. And 7A, it will need to gain 1 more to be one of the noble gas. That's why it has 1 minus. One exception is hydrogen. Hydrogen can lose its electron in a compound, or it can gain an electron in a compound. So hydrogen can be positive or negative charge. And when it's negative, it's going to be hydron. And we also learn about the polyatomic ions, how we have a list of polyatomic ions using nickel-cadmium, and all of them has negative charges except for the 2 polyatomic ions that are positive, ammonium and hydronium. You have to memorize them individually. And in today's lessons, we are going to look at how we can use the charges of ions to determine the chemical formula and the name of that ionic compound that will form from the 2 ions. So we are going to look at something like this. So here's the basic instruction here, okay? You are going to be given a cation, which is the positive ions, and an anions, which is the negative ions. And then we are going to look at those 2 ions to determine the chemical formula, okay? That is the structure that we use to represent a substance using the element symbols. And then we are going as well to determine the name of the compound, which specifically is ionic compound, which make from ions. And the method that we are going to use is this. But before we look at the methods, we have to look at the structure of the chemical formula as well as the name. For all the ionic compound, it will always follow this structure. It will always list the cation first, which is the positive ions, followed by the negative ions. So cations followed by anions. It will always follow that structure first. Notice how we have a positive and negative. So therefore our goal is to balance out the positive and negative, because the purpose of making a compound is that they have a net charge of 0. Because when an atom or a compound has a charge, it is unstable, and therefore it will be reactive to another substance until it has a net charge of 0 as a whole thing. Okay? And the method we call is the Crisscross Methods. And think of crisscross. You basic crisscross. As simple as that. But the only thing we're going to crisscross is just the number. Okay? Specifically the number. So keep that in mind. Now let's try one problem together to explain this crisscross method. For example, I have this right here. This cations and this anions. So we have a positive 3 plus and a 2 minus. So let's use a crisscross method. Notice how we only crisscross the number, not the charges. So I'm going to crisscross the number, which in this case is 3 and 2. So I want to take down the 3, and the way it works is that 3 is going to represent the number of oxygen ions, or specifically oxides, where the 2 right there would crisscross and carry down, and that 2 would represent 2 aluminum ions. And now we have our chemical formulas, and the way it works, we just rewrite them. So basically we have Al2O3. So the 2 and the 3, these numbers are called subscripts number. And subscript number, think of the term subway. You know how the subway go under the ground. In this case, the subscript is a small number right below the element symbol, and it represents how many of that specific element, or specifically the number of atoms of that element. So here I would have 3 oxygen atoms, and here I would have 2 aluminum atoms. So let's test if this crisscross method actually works. I have 2 aluminum. So aluminum is Al3+. So I have 2 of it. And that will give me a total of what? That is a total of 6+, isn't it? Now for the negative, I have 3 oxygen. And each oxygen is O2-, so I have 3 of it. And look the way it works. Now we have 6-, and this cancels each other out. So this method actually works. So our chemical formula is Al2O3. But what about the name? The name is extremely easy. You just name the way you see it. This is aluminum, followed by the N ion. So what's the name of oxygen? If we go back to the table, remember the naming structure? Oxygen become oxide. So we have aluminum oxide. So the name is aluminum oxide. And that's it. Here, let's try another problem together. Here I have my 2 ions, but this one's an N ion and this one's a cation. So let's go back and label the naming so that way we don't have to worry about that later. Okay, so N3-, that is nitride. And this is calcium because it's positive, so it's just the name of the element, so it's calcium. Now, first of all, is the order correct? No, it is negative and positive, so we have to switch it. In this case, we're going to have calcium 2+ and N3-. And we're going to use the crisscross method where we're only going to carry down the number. So to carry down the number, that's a 3, and that 2 represent the number of nitrogen. And that 2 right here represents the number of nitrogen. So what we're going to have is this. Ca3 and 2. Now let's prove that this technique actually works. How many calcium do we have? 3. So we have Ca2+. That gives us a total of 6+. Then we have nitrogen, which is N3-, and that gives us a total of 6-. So they cancel each other out. And that tells you that this chemical formula is really truly the chemical formula that we'll make from these 2 ions. And the name of this chemical formula, of course, is going to be calcium. That's the name of this one right here. And nitride. Isn't that easy? Let's try another problem together. Ooh, let's try this one with a polyatomic ion. Ooh, let's try this one with the polyatomic ions. Here I have calcium 2+, and then phosphate. And remember, phosphate is one of the polyatomic ions. So how is that going to work? First of all, we're going to do the same thing. Cations and ions. Check. That's done. So we know this whole entire thing is called a phosphate. And this is called calcium. Okay? And we use the same crisscross methods, which we know this 3 is going to be crisscrossed and carried out to represent the number of calcium. So we have 3 calcium. Then this 2 is going to crisscross and carry down right here. But wait a minute, don't we have this number already? A 4 right there. What are they going to do? Are we going to have 2 numbers next to each other? Of course not. Remember we talked about polyatomic ion is a single ions that made up 2 or more atoms. So just like in math, where we use parentheses to group things together, we're going to do the same thing in chemistry. We're going to group them together with the parentheses. That tells you that 2 of the whole entire thing. See how that works? So that's the beauty of parentheses. Now we can group the ions that has more than 1 atoms together. So our answer is going to be Ca, which we know is going to be 3, and parentheses PO4, 2. That 2 right there represents there are 2. This 2 right there represents there are 2 of these polyatomic ions, phosphate. So let's prove that this method actually works. We have calcium, which is 2+, Ca2+, and Ca2+. That gives us the total of what? In this case, is 6+. And for phosphate, each of the phosphate is 3- PO4 3 minus. Notice how we have 2 phosphate right there, right? And the total is 6 minus. And look at that, it cancels each other out. And what about the name? Simple, very easy. Just calcium. I just named based on the name of the ions. And this is phosphate. And that's all we have to do. Let's try another example problem with polyatomic ions. How about that? How about this one? We have sulfate, SO4 2-, and ammonium, NH4+. So they are both polyatomic ions. Now, is the order correct? No, because this is negative and a positive needs to be first. So we need to write it out. So NH4 plus SO4 2-. And we're going to call this, we know this already, this is sulfate. And this is ammonium. So that way we don't have to worry about the naming later, okay? So now the order is correct. Let's use the crisscross method. I just have a plus right here. So what does that plus tell you? What numbers must be in front of it? Of course it's going to be 1. So our number 1 going to crisscross and carry it down to represent, hey, I have 1 sulfate. And then that 2 right there going to be carried down and represent, I have 2 of ammonium. So the way it's going to work is like this. We have NH4, okay, but we have 2 of it, so we have to group them together. So there are 2 of ammonium. And for sulfate, we only have 1, so we don't have to put parentheses at all, because there will be no conflict with number 4. So we just have SO4. So let's check our work. 2 ammonium, which is NH4+, and sulfate is just 1 SO4 2-. And notice how the positive is 2+ and the minus is 2-, so they cancel each other out. And there you go, we have our chemical formula. And what is the name of this? Extremely easy. We just take the name of a cation, which is ammonium, followed by the anions, which is sulfate. And that's all we have to do. Let's have this problem here. We have calcium sulfate. So first of all, is the order correct? It is. We have a positive cation and a negative anions. Then let's look at crisscross method. We have to carry down the number. But look at this very carefully. Notice how we have +2 and -2 already. Isn't the charge already cancel each other out to become 0? So we don't have to do anything. All we have to do is just write out CaSO4. Because really all we need is just 1 calcium and 1 sulfate. And the charge is equal to each other, so it cancels each other out. That's all we have to do. Isn't that easy? And of course the name is going to be calcium sulfate. Okay, and we can prove that calcium is 2+ and sulfate is 2-, and we have 1 of each, and they cancel each other out. Isn't that easy? Here I have PO4 3- and aluminum 3+. Of course we know this is phosphate. And this is aluminum. And if you still struggle with the name of the ions and the chemical formula, please study that first, because that is like the basic of this, okay? So is the order correct? No. This is negative, so we have to reorder them. In this case, Al3+ first, PO4 3-. And notice how we have 3+ and 3-. Look at that, they cancel each other out already. So we have 1 aluminum and 1 phosphate. So we just put aluminum, PO4, and we're done. We don't have to use parentheses to group the polyatomic ions together because it's just 1. And our answer in this case, this is the chemical formula. And what's the name? Aluminum, followed by phosphate. Isn't that easy? And lastly, let's try our last problem together. In this case, we have hydroxide, which is OH-. That is something you have to remember individually. Hydroxide and cyanide. Okay? So this is hydroxide. Okay? And then this is calcium. And the order, of course, is not correct, so we have to reorder them. Ca2 plus and OH minus. And of course, here we have a minus. There's no number in front of it. We assume it's going to be 1. So we're going to use a crisscross, carry down the number only. Okay, so notice how this crisscross has 1, and this one 2. That 2 represents our 2 of OH. So what we have here is going to be calcium 1, but we don't write the 1. But then we have OH, which in this case we have 2 of it. So we have to group them together. Get this whole thing function as a single unit. And then our answer is Ca parentheses OH parentheses 2. Let's prove it. Ca is 2 plus OH, in this case we have 2 of it. Notice how we have minus 2 total, and this is just minus, and this is plus 2, and they cancel each other out. So this is our answer. And what's the chemical formula name? Calcium hydroxide.